should be live. So welcome everybody to Awkward Devs number 127. First thing quickly before we get into it, we have the Glacier fork happening in 2 weeks for anyone listening. So it's happening on December 8th. If you run an Ethereum mainnet node, please upgrade it. In the agenda for this call, there's a link to the Glacier spec with the release versions for all of the clients. Again, the Glacier is just an upgrade to the difficulty bomb, so it doesn't do any kind of substantial changes. And yeah, you want to upgrade before December 8th or block 13.773 million. With that out of the way, Mikhail, I saw you had a couple points you wanted to discuss about Kintsugi. I think we can probably just get a quick update from the different client teams and then dive into those. I don't know if any team wants to start and share kind of their progress over the past 2 weeks. I know there was some syncing that was happening this morning or last night. And I'll call on Marius because I know Geth was one of the syncing clients with, I think, Teku. So yeah.
Yes, I can go first.
Sure.
So the devnets, I'm not sure if we talked about devnet 0 on the last call, but devnet 0 basically broke because I ran 2 miners at the head, which meant we had like 2 competing proof of work blocks, and clients were not able to fork to the correct one, or like to fork after the proof of work was after the proof of stake chain started, which meant that like half of the network was on one chain, half of the network was on the other chain. This is not really fixed yet, so we have to think more about how we can make sure, or how we can work with these forks around the terminal proof of work block, and also maybe how we can show that to the user, to make the user aware that there are 2 forks and that he has to decide between them. And then like we can have a social consensus on like the right proof of work block and then build on that. And that was the first devnet. The second, or devnet 1, it's 0 based. Devnet 1 broke because I made I wrote a bug, but we have updated Geth now, and we fortunately Nethermind was correct, was correctly producing the chain, and we then fixed Geth and synced to the chain. And I think currently on the chain it's Nethermind Geth, BISO, I'm not really sure. And for the consensus layer clients, it's Lodestar, Lighthouse, Teku that are currently running, I think. And it's going okay. And I also tested today, the optimistic sync with Teku, which were like there was a bug in Geth that prevented Teku from optimistic syncing, but that is also working.
Nice.
So for the Teku team, it works. It was just a bug on our side, and we're going to fix it. That's basically it.
Wow. Yeah, great progress. Anyone from any of the other client teams want to add some more context?
Yeah, Okay, so from Nethermind, we have to do several not critical fixes and quite lots of refactoring. Our sync process allow us to work in any devnet. However, this is not our final solution. We plan to rebuild it. We are in sync and we are producing blocks on Kintsugi devnet, like Marius said. It seems that Nethermind is working fine, and we will definitely continue testing different client combination. And yeah, I think that is update from Nethermind.
Thanks. Anyone else?
Yeah, from base2, we've implemented the Kintsugi spec and we've successfully interoped with merge mock, but we have been focusing more on trying to get our merge branch merged into main. And we haven't tried to interop on the devnets yet. We're at a point now where we probably could do that, but we aren't at a point where we can do that with the main branch. So yeah, we'll probably jump in with a client from our merge branch instead.
Got it. Andrew, you have your hand up?
Right. So for Aragon, we're still developing the merge. So we haven't been able to sync yet. I have a question about the merge. So now we have EIP IP 4399 as well, and there is but IP 3675 says that mix hash should be 0, while in IP 4399 we are reusing mix hash. So can we actually clarify IP 3675 so that mix hash doesn't have to be 0?
I put in a PR, I think, 2 days ago to clarify that.
Yeah.
But
actually, my audio seems to be broken.
Oh, no,
you all hear me?
You're good, Danny. Yeah. Yeah, you want to explain?
I can't hear you. Yeah.
Okay. I think I can explain it. So yeah, we put in a PR in 3675. I think we just added a note saying like that these parameters that are set to 0 can be overridden, based on subsequent EAPs. Didn't want to assume that like every implementation, like if there's another network or something that wants to use 3675, that they'd also use 4399. But yeah, I just tried to make it clear. And yeah, the 4399 does supersede basically 3675. So you do use the mixed hash.
Right, cool. Thank you.
Yeah, and Mikael shared the PR in the chat. Yep. Cool. Perry, I see you have your hand up.
Yeah. Hey. So while the aim of merge.net 1 wasn't to test the like random transactions, etc., there is, however, a faucet deployed. So if someone has interesting edge cases they want to try out, please claim some ether, test it out. I'll also just share a couple more resources. So if you find something to break, feel free to break it.
Also, if people are testing the execution layer, there's a 4399 transaction or difficulty before the merge and random opcode after the merge. So both is in the testnet. So if you don't have 4399 enabled, then you cannot sync the post-merge chain. You will crash on block 1641, I think. So just, yeah.
Got it.
FYI.
Cool. Any other updates from teams working on this? Okay. In that case, Mikael, you had 2 issues you wanted to discuss. The first was the message ordering for the engine API and how do we reset request IDs?
Yeah, so there is the PR to engine API that defines the message ordering section. And the one corner case was Yeah, it's dropping the, yeah, oh, thanks, Tim. I dropped it as well. Okay, so there is a discussion about one edge case scenario. Let me just give you a quick context. What's the edge case is. So we are, it's very important that fork choice updated messages are propagated in the same order as they appear in CL. And for this purpose, we use request ID, JSON RPC request IDs. So they must be constantly increasing, and EL must not process fork choice updated method calls if they have the ID that is lower than the previously processed call of this method. That's how it's that's how this PR proposes to adhere to the message or to the order of fork choice updated events happening on CL. And the edge case then suppose when CL just went offline and got back and get back. So it will either need to persist the request ID to start from the same value. Otherwise, or we need to reset it somehow via engine API. Otherwise, the counter will start like, let's say, from some default value, which is 1 or 0, and execution layer will have to, if it follows the spec, it will just have to reject those messages until the time when the counter gets back to the same state that was before the restart of CL client. So, and yeah, the proposal for setting this counter is just if execution layer clients see that the request ID is 0, then it means that the counter reset and counting starts from like 0 and goes onwards. That's it.
This seems totally reasonable to me. The edge case is even worse than that. It's not just like one single CL resetting. Like CLA should be able to be swapped for CLB transparently to EL. And so anything that you have to persist across those 2 layers to be able to communicate after that swap is, worse than just resetting CLA. So I think the 0 makes sense to me.
Is there any like opposition to implementing it this way? Or if yes, you let's discuss it now. If not, if there is no strong opposition, you may just go to this thread, comment, put a comment there. Otherwise, I guess it will be merged pretty soon with this proposal, this resetting mechanism.
Cool. And there was a second issue you wanted to bring up also, to add ETH get block body, or sorry, engine get block bodies method.
Yep. Yeah. There is. It's a proposal yet. It's not even a PR. It's like a request for comments. But let me drop the issue. What it proposed is to implement get block bodies method in engine API. It allows for pruning execution payloads on CL side and save like potentially a lot of space on the disk. In this case, the CL clients will request block bodies, which is just the transaction list after the merge. Whenever it needs to serve a block, beacon blocks to the remote peer or to the user, it will just go to EL and request bodies and request transactions of those payloads that are supposed to be served. one thing worth mentioning here is that this get block bodies maps on the get block bodies message in ETH protocol. So I'm assuming that it's pretty straightforward for execution layer clients to implement, to expose this logic, this same logic via engine API, because basically the logic already exists and it just needs another one interface to be accessible. So.
Question, the response, do you expect it in JSON format or RLP encoded?
It's basically, it's the array of bytes according to EIP 2718. So it's either RLP or a binary encoded transaction according to this EIP.
Yeah, okay, but that's a single transaction, but the list of transactions is still RLP encoded. Yeah, okay. So you expect the consensus format, in short, whatever that is. So not the JSON format, rather the binary consensus format.
Right. It should be like, yeah, it's array of encoded transactions. It's not RLP encoded array of encoded transactions. Yeah.
I'd say something like this seems very reasonable. If this becomes a complexity, though, I think it can be a optional at the point of the merge and something that's pretty high priority to get in place after. Not that or even just utilization of the pruning mechanism, even if the method exists. But I think deduplication does make sense.
No, I mean the implementation of this thing is 5 lines. So
I missed that. What was that, Peter?
I was saying that the implementation of this execution layer side is 5 lines of code. So it's
cool.
completely reasonable to just add it to the spec as mandatory if you want. It's 0 effort to implement.
Okay, so mandatory as part of the spec, but whether CL is doing pruning at the point of merge or not can be optional.
Yeah, exactly. I mean, you can do whatever you want. Just
right,
if you make it mandatory, then you know that every client will be able to serve you, so you can swap out one client for the other.
Yeah, okay.
Cool. Yeah. Does anyone think we should not include it or like have it as an optional? Okay, I guess, Mikhail, you have your feedback.
Yeah, okay, so makes sense to open a PR probably. Or yeah, I'll just wait for some time and probably open a PR next week.
Cool. Anything else about Kintsugi or the current merge implementations?
I was going just to say that we are about to release the next version of Kintsugi spec pretty soon. Danny, do you want to add anything here?
Yeah, so I think as y'all are all aware, the devnets are now launched on Tuesday rather than Thursday. And we had spoken about attempting to do the persistent testnet next week or the week after. I think given progress and given some of the iterative changes that are still coming out on the Kintsugi specs, I think we'll be at a Kintsugi v3 by about Monday or Tuesday. I would suggest that we are aiming for the persistent testnet launch on the 14th rather than 7th, just to give us time to, I would say Kintsugi v3 specs are out Monday or Tuesday. So then the 7th can be a v3 devnet, and then the 14th can be a persistent testnet, assuming things are going well. I know that begins to push us close to the holidays, but I think it's at least reasonably far away from Christmas. But obviously, open to feedback on that, the shift in the timeline.
Answering the question Marius has, yeah, we will have the changelog and the Kintsugi spec in the table.
One thing I'll point out for the client team, so if we do aim to have, say, a devnet that's stable and that we want basically non-client people to use over the holidays, I think it was Infura and maybe Coinbase mentioned that just having it in master with a flag really helps. Yeah, so just if that's something that we can aim for on the client sides for like the December 14th release, I think it'll help just get more folks onboarded to it.
Not gonna happen.
Not gonna happen.
No, I mean, if the request was to have everything merged onto master, no, not that.
Got it. So it's still easier to keep it on a branch by then.
But the problem is that once we merge something to master, it's I mean, it's already, so to say, past preview, so nobody's going to just dig it up again to see if there's something wrong with it or not. So it's kind of dangerous.
Fair enough. I think, yeah, in that case, you know, having like a clean branch we can point them to, and if it's possible to have a command line flag on that branch, that's probably as good as we can do.
Yeah, that's reasonable.
Cool. Anything else on Kintsugi? Yes, Danny will be away for the next few weeks, the month-ish. So you're stuck with me and Mikhail. So we had two other topics from the last call that that we had kind of bucketed, basically how we do fork IDs for the merge, and the discussion around the IP 4444 and how, you know, we want to go about potentially implementing that after the merge. I think it's worth maybe moving to the next section first, because it might affect those discussions. So in parallel to that, in the past 2 weeks, there's been a lot of discussions about transaction costs on rollup and how we can potentially help alleviate those. And there have been two proposals kind of brought forward, which would kind of reduce the call data gas costs in different ways, potentially with the desire to see if those could be brought to mainnet fairly quickly, given that one of them is literally one character change. So I think it makes sense to maybe just have the authors, if they're all on the call, kind of walk through those proposals, why they're valuable, and get some general feedback there. And that, yeah, the impact of those probably determines like how we want to deal with fork IDs and what we have to do with regards to historical data. So let me see if I can. Yeah, is there an author of either of the EAPs that wants to give context?
I'm happy to talk about 4488.
Sure.
Okay. So the idea behind 4488 is that it decreases the call data gas cost from 16 gas per byte to 3 gas per byte. So it decreases it by more than a factor of 5, and this would make rollups five times cheaper. So like something like I think on average, Optimism and Arbitrum tends to be around the $2 to $5 range. You would bring them up under $1, and then Loopring and Zk Sync are often about a quarter, and it would bring them back under 5 cents. The one extra feature that the CIP has is that it also adds a separate call data size a limit per block. So it says that a block can have at most 1 megabyte of total transaction call data plus 300 bytes for every additional transaction. So this is like in terms of code, it's it's still fairly easy to implement. It's a one-line function, but in terms of consequences, this this does mean that instead of having a single dimensional limit, we have a two-dimensional limit. So there's a limit to gas, and there's a limit to call data. And historically, I think we've been wary of adding two-dimensional limits because two-dimensional limits make the algorithms for figuring out what transactions to include harder, because you can't just like take the top priority fee, then the next priority fee, and then the next priority fee, and keep going down until you run out of space. So the IP has a couple of mitigations to this. One is just the fact that we already did EIP 1559 means that the number of case, like most of the time, blocks are the constraint is not going to be block size. Most of the time, the constraint will just be like you take everything that's willing to pay the base fee until the mempool at that level clears, and then also just the fact that the limit is quite high. I don't think we've even seen a blocks today that rise to anywhere close to that limit, and so the average is somewhere around 15 times less than the limit. And also this extra stipend of 300 bytes per transaction, which basically says even if you create a block and that block fills up to the call data limit, you would still be able to keep on including transactions with less than 300 bytes of call data, which is on average about 90% of all of the transactions in the mempool. So the reason behind this limit is basically because historically we have been concerned about the possibility that if there is a really big block, then that would just temporarily crash the network in ways that we don't fully understand, because we haven't really had blocks of that size yet. And so this is basically just a keyhole solution. It says, well, you can't have blocks that are larger than a level which is somewhere between 1 and 1.5 megabytes, which is actually the same limit as actually lower than the current de facto limit of blocks. Like today, the theoretically largest block you can construct is 1.87 million bytes, and with this with the limits in the CIP, it would be between 1 and 1.5 million bytes, depending on the amount of gas and the number of transactions.
And maybe before we go to comments, it's worth just highlighting also kind of the other proposal, which was 4490. So this one would basically proposes to just reduce call data from 16 to 6. So a smaller reduction, but then does not add these mechanisms to cap the amount of call data in a block or the transaction stipend. So it's just like a one-line change to the actual gas cost of call data in transactions. And Micah, I see you have your hand up.
It's for a comment. You said no comments until after you talk about that.
So so sorry, that was like the overview of the second proposal. Basically, just
okay.
Yeah.
For 4488, why have the gas per block as a function of the number of transactions in block, rather than just having the gas per block be a fixed value? Like if our goal is to target, make sure blocks don't get too big, why don't we just say
right? So this mitigates the two-dimensional optimization problems. Like basically that the problem with adding any kind of extra limit other than the gas limit is that it means that the naive algorithm for filling a block is not going to be optimal anymore, which would mean that like either we have to actually implement some much more sophisticated algorithm, or blocks created in a non-standard way are going to be more profitable, and so like more people are going even more blocks are going to be created through flashbots. So the idea behind the 300 byte stipend per transaction is basically that if you still create a block using the current naive algorithm, and your block fills up to the call data maximum before you run out of transactions or before it hits the gas maximum, then you would still be able to keep on including any transaction with call data less than 300 bytes. So you'd still be able to keep on including 90% of the mempool.
And just to briefly add to that, like it's important to note that basically in the extreme scenario, so like say rollups become very popular while this is in effect, and you have one big rollup transaction every single block, more or less, that would fill up almost all the call data. This would also start interfering with the 59 algorithm, right? Because basically, if you don't have a stipend, then after this rollup transaction, there could only be ETH transfers because those are the only transactions that don't consume any extra call data. But you might just not have enough ETH transfer demand at the kind of base fee level, and so the base fee would be artificially depressed. And then you basically have the rollup transactions doing a first price auction again on the priority fee. So basically, this just ensures that blocks can be produced as normal.
Mm-hmm. Right. So like in that kind of extreme world, basically the rollups would sometimes end up competing by setting high priority fees. And if your transaction is one of those 10% that has really big call data, then you would have to push your priority fee up to compete with the rollups. But if it's under 300, then you would still be able to get in with the same usual priority fee of 1 to 3.
Andrew, I see you have your hand up.
Right. I'd like to relate Alexei's concern, and his concern is that with this change, we might incentivize, we might actually prohibit the adoption of data sharding because the input data on the execution layer will be so cheap that actually nobody will be incentivized to move to like data sharding. That was his concern.
Got it.
Can we do a quick rebuttal on that before we move on?
Yeah, go for it.
Oh, just the data sharding one would have eventually much more capacity than what can be provided there, and does not have the competition mechanism for additional execution. And so I think naturally you would see the move to data sharding because one, that would be like capacity would be exceeded, and two, you likely can find cheaper data elsewhere. If that actually became a problem in like the overuse and abuse of that mechanism, you could have a fork to up the gas price of that after you had sufficient data sharding.
Right, so this would be kind of a temporary fix in that worst case scenario where
yeah, I'm not necessarily advocating for having to update it, but that is something that could be done in the future if we really needed to directly incentivize moving to data shards. But I suspect that's something.
I mean, I think generally there's a strong case for just reversing this change when we have data shards. Why not?
Right, and I guess one thing in the chat that Enskar said is obviously sharding is probably still a couple of years away, so it's kind of a medium-term problem contrasted to like the current state of just high fees on the network. Martin, you have your hand up.
Yes, and we're wondering a bit about possibilities to game this algorithm. So say you're a miner and you've just filled it to the full base max call data per block, but there's another juicy transaction about 600 bytes that you want to include. So therefore you make 3 tiny transactions that just, I don't know, are at the minimum. That frees you up, gives you another 900 bytes that you can put into the block. Is that something that can feasibly happen? And is that something we should think about and be concerned about?
Right. So actually, this is in a sense intended. So basically, the idea is to say that in a block, the first megabyte of call data is really cheap. You basically just get that more or less for free, and you just have to pay the normal call data pricing, that the reduced 3 gas per byte for it. Then afterwards, call data just becomes really expensive, meaning that basically for every 300 bytes you want to consume extra, and 300 bytes is like a super tiny fraction of the 1 megabyte, right? So then for every 300 bytes you want to consume extra, you basically have to include one more transaction that's like basically at the minimum 21,000 gas. And so if you really if you're in this situation that say you have a 600 byte transaction and you're really willing to pay quite a bit to get that in, even if you're not willing to compete for this prime spot in the beginning of the block, it's perfectly fine to even, I don't know, say use flashbots to create a bundle where you add an ETH transfer in front or something. Again, this would be like a super rare workaround, but basically the idea is just that it makes call data after this first megabyte expensive. It's not that there's a hard cap of 300.
Yeah, you don't actually need flashbots. You just send a series of transactions with the same sender and sequential nonces.
They might end up in different blocks though, which would.
Okay, yeah, that's fair.
Yeah, so what I'm worried is basically, or what I'm see as a potential problem is if we suddenly start getting these padding transactions included into the block just to push it a bit further, but the padding transactions are basically useless and just take up block space.
Right. But just so basically the padding transaction would only be a workaround for inefficient mining algorithms. So because if the miner runs the mining node that actually can deal with this, then it kind of just reorders the transactions because they again, the 300 bytes is chosen in a way where 90% of transactions are below it. So if you basically, once you kind of deduct the big 1 megabyte rollup transaction, the rest of the block, kind of almost in all circumstances, would on average consume less call data than 300 per transaction, basically smoothed over them. And so kind of the only problem that can occur is just that if the miner naively assembles the block, they might skip a transaction with 600 call data. Even if they just ran all of them, it would still on average just work out fine and the block would be valid. And so if they're smart about it, this will just never happen. And so this is really basically just a workaround for either miners that just run an inefficient mining algorithm, or the very occasional block where the average is even for after the big call data transaction is through average call data size is still above 300, but this might be worth looking into blocks, but I would just assume that's basically I don't know, one block a day or something, and having 2 or 3 padding transactions a day shouldn't be a problem.
Right. Yeah. Basically, I think it's a very exceptional case because it would be both for the subset of transactions that is bigger than 300, and for the transactions in that exceptional case where call data actually is going over the cap. And also the other, it would have to be a situation where priority fees are getting so high that padding with junk transactions is a cheaper strategy for that sender than just bumping up their priority fee, right? Because if you're willing to add on a bunch of junk transactions, then you would also be willing to add on a pretty big priority fee. So that would be my answer. If we really want to make this not an issue, we could basically say that there's the possibility of redesigning the EIP to basically say that data under 300 bytes doesn't increase the stipend. So instead of saying it's called the total call data has to be less than 1 million plus 300 times the number of transactions, we would say the total number of bytes exceeding the byte number 300 of each transaction can't exceed 1 megabyte. So I guess that would be less exploitable, though that would also increase the number of times in which the limit actually gets hit, basically because just people's random accidental or ETH transfers would not increase the limit.
Yeah, I don't really have an opinion about it. I just wanted to hear your reasoning about it.
And just for the record, if this would really be a sustained concern, then basically I'm sure we would find someone who would be willing to just write an optimized miner algorithm that is smart about this. So this won't be relevant. If no one else would do it, I mean, I'd even be happy to do it myself.
Lucas, you've had your hand up for a while.
So is this possible that it will incentivize miners to like skip the huge cold data transactions and have an effects opposite of the desired?
And why would that be the case?
So, for example, it makes the block smaller, so they can, I don't know, propagate them quicker, etc.
Right. So that's actually a good point. I think if we look at, say, the conversations around what is the expected optimal priority fee, there was some kind of reasoning that like we would expect a priority fee slightly above 1 way to account for the increased anchor risk of basically having bigger blocks. And so it could well be that indeed miners choose to demand a priority fee of above 1 way specifically for big call data transactions, right? This would be a trivial rule to add. You could just look at the call data, and if it's above some threshold, you basically say, okay, I ignore transactions if they don't at least have 2, 3, 4, 5 way, whatever the miners choose to account for the anchor risk. But this should like be just a normal, simple kind of economic decision, and then there's this simple level of the priority fee. So it might well be that rollups just have to pay a little bit more priority fee just to kind of like make miners whole there.
And I guess in this instance, a bit more is not 5x, right? Like probably not enough. To,
Yeah, and that would only happen in the like dream world where we actually are getting a megabyte of rollup data every block.
Yeah, Dankrad, I saw you commenting about this week, and I think you feel pretty strongly this is something we should do sooner rather than later. So do you want to take maybe like a minute to explain kind of your position and like why you think this is really important, and like, yeah, and probably should happen
I
sooner
mean,
rather
I
than
think
later.
right, yeah. I mean, I think like this is like an amazing opportunity we have. Like if we think slightly less like only about the tech and risk side, but also about, well, I've said before, it would be nice to have some users on all core devs, because like fees of like hundreds of dollars are crazy. And like everyone talks about this, like literally everyone in the crypto universe. And like we're pushing users away left, right, and center. And like this would be the opportunity of a lifetime probably to like show that we're doing something and actually be doing something, and in I think actually sustainable way, because we do have a long-term solution for the rollups. So it's just like a temporary kind of subsidy, you could say, for the rollups in order to push this. And I would basically argue that we should try to just get this done like even this year, even if there are some risks associated with that, but I think it's a very simple change, and I think that would show the community that like we really do care, and ETH is still alive and punching and isn't like completely ossified and can't even make a change like this in several months.
Well, I mean, the theory sounds nice, but I think you seriously underestimate the effects that it has on every other part of the system. I mean, of course, it's a one-time change to drop the gas limit or the gas price. But for example, gas currently limits transactions to be maximum 128 kilobytes. Now, if you all of a sudden you want to allow transactions going up to 1 to 2 megabytes, that's a gigantic change. That's an order of magnitude change on the network traffic.
But do we need to do that? I don't see why we need to increase single transactions. Like a rollup can simply use like 2 or 3 transactions to load all their data into the block. So I don't see why we need to change that.
Well, they would use, well, if you want to use 1.5 megabytes, that would be 15 transactions or 12.
Is that a problem?
Not for me particularly.
Well, I don't know how rollups are currently constructed, but I think the teams are probably much better at making quick changes than we are. And so if they need to pack it into 5 transactions to make use of this, I'm pretty sure they will.
Yeah, there's 2 very clear, clean mechanisms to do that. One is they just limit the size of the blocks and be able to check in multiple blocks in a single L1 block. And then the other is there already are mechanisms. I think Optimism uses this, where Optimism preloads the data in a transaction and then uses the subsequent transaction to essentially check in the data. And so you could do batches on the first rather than needing a monolith. So it's very technically feasible.
Doesn't
even with just 138 kilobytes
already?
Yeah.
Sorry, what did you say, Vitalik?
I was just saying, doesn't Starkware use those tricks already? Because like I think their Starks are going to be awfully bigger than 128K.
Yeah, it seems likely.
So the reason I kind of brought it up is because I think the past week or so, I think Arbitrum was opening issues on the Get repo asking whether we could raise the transaction limits to 0.5 meg. And essentially, I mean, there's definitely a sweet spot. 128K was kind of put there as a sanity limit. We could go a bit up, but so the problem is that as long as nobody is actually using 128K transactions, or maybe there's one per day, it is almost impossible to see what the effect of this is on the network. So
I think that's an orthogonal issue. I mean, it's certainly something interesting as well, but I would say this is completely orthogonal to this change. I would not say like if we make this change, we have to make that change as well.
Okay, but okay, then in the same vein, the other downside, which I think is also mentioned in Vitalik's EIP, is the growth. So essentially, if all of a sudden every block would max out its capacity, I think the EIP mentions that would be about a 3 terabyte chain growth per year. So what do we do about that?
Yeah, and this was my comment as well, that I agree with what Peter said last meeting, which was that while we don't need to implement EIP 4444 right away, we need to commit to implementing 4444 in the future. And 4444, for those who don't remember, is the one where we assert that we're going to start dropping historical bodies and receipts. With that, then the history growth is much less of a concern. Without that, then I agree that's like a big concern. So I don't have a problem with the CIP as long as it comes with the promise of committing to 4444 eventually, which means we advertise to users today that, hey, we are going to be dropping history, rewrite your dApps to not rely on infinite history storage.
I totally agree. And proof of stake switch is a great time to begin to advertise that promise and to develop a group that figures out what the pain points are and helps to resolve them, on the order of 7, 10, 12 months time.
Yeah, so kind of that's what I was also wanted to go towards, is that, I mean, so the thing is, what we kind of need to be aware of is what the timeline would be. So, I mean, we could commit to 4444, saying that yes, we will start dropping, but we kind of need a realistic attack plan for the whole thing, because just promising that we will do it someday and then the chain just grows wild in between is a bad place to be at.
I think that we can reasonably form a working group that pushes this out by the end of 2022. I mean, with an even more aggressive timeline potentially being available, I think a lot of the changes, a lot of these things don't have to concern this group directly. And so it can be done in parallel without taking a lot of resources from this.
Yeah, well, yeah. So from my personal perspective, if we can get the 4444 off the ground, then I don't see any particular issue with it. Probably it will be a bit weird, a bit hiccupy when you all of a sudden you'll have large blocks appearing. So I'm kind of curious how the network will take it. But yeah.
I think we have tests on that, right? There were tests. I don't have the data in front of me, but that has been done in the past.
Yeah, I'll drop the link right here.
Maybe also comment on 4444. I mean, I think that is the assumption for data shards already anyway, that such a mechanism exists. So I see it as a given that at some point we will switch to such a mechanism. Maybe a question on this. So right now, the only real concern about having this large chain data, like realistically, I could run a node with dropping all the chain data, except that I'm not a fully functional peer-to-peer client, right? That's people could request data from me, and I can't give them those blocks because I don't have them.
Also, there are a large number of applications out there that will not work if you don't have history.
Okay, I see.
Which I think is the harder problem that we need to do some community outreach to solve.
Primarily receipts. Is that the mechanism that we're worried about here?
Yes, there are some who also use call data, which annoys me greatly, but receipts and logs.
Didn't like or the Ethereum clients stop serving transactions older than a year? I forget what the exact change was.
So no longer stop indexing transactions that are older. So if you cannot look up transactions by hash, but if you know that you want transactions from block 5, then you can retrieve the transaction.
Okay, got it.
Right. And that's what a lot of apps do, is they just troll through all of block history and ask for the logs for every single block in history.
I think that's generally okay though, because if they're doing this to populate their own database, then we can just require them to download those out of band and run them through maybe a more sophisticated client. But I'm like worried about the case where the dApps are literally calling your local client and they're requesting historical data.
Right.
So I guess like my impression would be that a lot of those applications are going to be crazy slow in the world where you're not talking to Infura already, right? Like there's a bunch of dApps that already basically even had to switch to the graph because like using Ethereum's built-in like log querying for very long time spans is just too slow.
Yeah, the one issue I have with that point of view is that we're basically saying everyone who built their app to be censorship resistant, sorry, you're screwed. Everyone who is using a centralized server, everything will be fine for you. That's
not necessarily what's being said, because being able to get historic receipts and compute them in some way, like and get historic blocks and compute them in some way, should be part of 4444. Also, being able to index them in a sane way should be part of 4444.
And I think I think it can be done, especially given that I'm expecting to have a serious push for the revival of light client usage. And now that, especially past the merge, now that we have Altair, and now that very efficient light clients are possible. And once you have light clients, then like if you have a one of interest model, then like doing history queries and doing log queries and everything is pretty simple.
Just to, I guess, kind of bubble this up a little bit. So obviously there's concerns about chain data growth, some concerns about just like the max transaction size, which are we can kind of sidestep for now. We spent a lot of time talking earlier about like the kind of optimal block packing strategy. I'd be curious to hear, like, just between the two proposals, like, do people feel like having a lower call data cost with a couple additional constraints is significantly harder to implement than just changing the actual call data cost? Or basically the flip side of that is whether just changing the call data cost, even if it's not lowering it by as much, is already kind of too much in terms of the worst case block size. So there's not a world where we just lower the call data cost because we need some cap anyway. So I guess, yeah, kind of a roundabout way of asking, like, is there basically like a proposal people feel is more realistic, or like, simpler to implement. Yeah, just so we can kind of focus the conversation. And otherwise, more explicitly, like, would, say we just reduced from 16 to 6 and had no other mechanism, so no cap in the block and whatnot, would that be, you know, chain data growth aside, which would be slightly slower than reducing to 3, you know, would that be reasonable?
So that would be a maximum block size of 5 megabytes. 30 million divided by 6.
Yeah. That seems worse to not have it. And I think the additional complexity is probably minimal to get the additional validation rule in.
Does everyone agree with that?
I think I agree, as long as we're okay with punting the block stuffing strategies to searchers and professional block producers, and we just say, hey, it's their problem. Because in that case, it really is very easy to change. It's one line, basically. If we want to force the Geth team, on the other hand, to go and design a better block stuffing strategy, then that costs, you know, core dev time significantly more.
And again, just to reiterate there,
as a proof of stake, all the clients.
Yeah, but I mean, just to reiterate there, like that's basically exactly what the stipend mechanism is supposed to address. So, like, I mean, we talked about it earlier, like, but with the, even if you do the naive thing, it's already basically, you already get 95% to our optimal blocks. You have the occasional situation where it's maybe a little bit suboptimal, but it's very close to optimal, even with the naive implementation.
Right. So if everybody's okay with that, then I don't have any problem with 4490. No, the other one.
4488. Yeah.
Yeah.
I guess, can we get like a client team to confirm or say they have no idea and needs to look into it more? Oh, I see Gary is unmuted.
Yeah, I was going to say, I don't think Besu has a significant portion of mainnet mining, but I think that we're okay with making this change.
Got it. Edgar, your hand is still up. Is that just, do you have some?
No, this time it's actually on purpose.
Okay, perfect. Yeah, go for it.
Yeah, no, I just briefly wanted to kind of try and bring this back on timeline discussion, because I generally agree that the kind of a general commitment to something like 4444, or just in general, basically that we say that in the medium term we expect, or like we are certain that the chain, like that clients will no longer by default provide all the history. Basically, if we are certain about that in any version, right? Like it doesn't matter like how exactly we end up doing this, but like then I think something like that is indeed would be important here. But at the same time, I would want to say for context that right now we only have a few rollups live on mainnet, and those usually only settle very occasionally. I mean, I haven't looked specifically into optimism, but like ZK saying concerned that's, I think last time I checked it was every couple of hours. And so there's a long way to go between the current situation and the situation where they settle every single, where like one rollup settles every single block. I mean, hopefully, of course, we get there, because that means we have more adoption, but it won't be that like we turn this on and we immediately have a kind of yearly growth of 3 terabytes. This would be like the long run situation. And even then, like it would take a year to get to the 3 terabytes. So I think it's something where, as you were saying, as long as we're kind of reasonably certain that by the end of next year, we have some version of history, limiting history in place, or even by, I don't know, early mid 2023, this would be perfectly fine. The question is just like, are we busy? Because if I think a lot of people here would really want to see this change in a like special purpose fork before the merge, and for that, of course, the timeline would have to be quite accelerated on decision making. And the question is like, if it takes us a lot of time to kind of like discuss the details of 4444 on the way there, basically, how comfortable are we with already making a preliminary decision on like a special purpose fork for this before we kind of fully worked out the details on 4444? I think that's really the main question.
Right, and I guess maybe to like give some context on the timeline, you know, the default say path if this was accepted is we'd say like, oh, it goes into Shanghai. And realistically, you know, Shanghai is like a year away, plus or minus a quarter. And, you know, the pushback there would be, well, transaction fees are already super expensive. They're like non-trivial on rollups, and like waiting another year to reduce them is just really bad. And so basically the options you have is then like there's something between the merge and Shanghai that's just this. And then, you know, you also open up the can there of like all the other things we want to do after the merge. Then obviously with the merge itself, that's a fork. And you know, we're already making 2 EIPs there. The trade-off is you're obviously adding more complexity to this already massive upgrade. The other thing is we discussed on the last call, potentially having like an empty fork before the merge to just set the fork ID for the merge. And so that's a time where like we might have to get everybody to upgrade their nodes anyway. And then the other option is like you have just, you know, a completely separate fork with just this. And at the risk of potentially pushing back the timeline for the merge, I think that's the other thing. It's obviously, you know, people are very excited about the merge. You don't want to push it back for, you know, for a bunch of reasons. So if we have a completely separate fork, you know, is that actually pushing things back, or is that maybe the most efficient way to do it? Because then you're just separating concerns much more. I think that's kind of the timeline discussion. Like, the way I see it is like either we have something completely separate, either we bundle it with like some fork ID change or with the actual merge itself, or we basically wait until after the merge, and then the problem is just, you know, high fees on rollups basically persist until then.
So the fork ID change wouldn't be 2 software releases. So like that would be, say the fork ID changes 2 or 4 weeks before the merge is supposed to happen. You upgrade your node before then. You don't upgrade your node a second time later. So if you coupled this or anything with that, then you now have coupled them inextricably, and so you don't do that release until the merge is ready to be released. And so I think that if you do want to do an aggressive timeline for this, tightly coupling that in that way actually encumbers things and makes things a bit harder rather than doing something independent. My 2 cents.
My 2 cents would be not to couple this thing with the merge, because the merge is messy enough by itself and you don't want one extra stuff to debug. Now, as for whether to do it before or after, I guess if somebody just creates a proof of concept PR to see what it would take, then it might be interesting to consider whether we can ram it in before the merge without delaying the merge. If not, doing it after the merge, the only downside there is that that will take, I don't know, half a year at least. The upside would be, however, that after the merge we would have a nice, simple, so to say, hard fork to test out how we can fork stuff post-merge world, which isn't a bad thing either to have.
Is it? Oh, sorry, Ansgar, go ahead. And Drew after.
All right. I just wanted to briefly mention so that Quilt looked into just as for curiosity into like an implementation of 4488 and basically implemented it in Geth, untested yet, so it's kind of like definitely only like a prototype, but that was pretty straightforward. So I don't think implementation complexity would be high. And just the other comment that I would want to make. It's just that I think we have talked in the past repeatedly about that there's a problem with the Allcodev's governance structure, and that like user voices are kind of underrepresented. And I think this is really kind of like by far the most kind of purified example, or no instance of this, where I think we basically like I think that the user side is very overwhelming for kind of trying to do something like this before the merge, if there's any chance for it. And listening to it, at least it sounded like on this call everyone was at least ambivalent, so like I didn't hear any strong opposition against this. So I would just kind of like argue that we should do this before the merge, because we are more or less ambivalent, but the community is like very strong. I don't want to overstate it, but like it seems like the community is very strongly in favor of something like this before the merge. I even saw a lot of people saying like, yeah, if the merge is delayed by a couple of weeks, and I don't even think that's necessarily the case, but like even if that was the case, that would be more than worth it. So I really think that we should kind of like try, and even if no one is on the call here, like to represent this kind of this broader set of people, but like I think we should really keep in mind that that is an important.
Yeah, I think we should treat it as very urgent, and we should do it before Christmas. That's my opinion.
I agree. I agree with that 100%. I think it's will provide the change in both in narrative and cost for users to do the migration to rollups in general. Read from Starkware.
Thanks for sharing. Andrew?
I think it's not a good idea to do it along, like at the time with the merge, because yeah, I agree with Peter that the merge is already complex enough. And if we decide to do it before the merge, my slight preference would be to go for the simpler 4490, because it's a kind of a more trivial change than 4488.
Got it. And is this based on like Aragon's engineering capacity, or just on like analyzing kind of the second order impacts of the change?
I think it's the second order impacts, because like it's not hard to add an extra validation, but like there might be implications for block proposers and so on.
So would it be valuable to say like in the next couple weeks get feedback from, I don't know, say Flashbots, or I don't know what team, like some team that has experience in like the mempool, to see, you know, how easy or hard it is to have an optimal strategy? Would that like help with these concerns? I know Aragon also has like a separate design for the transaction pool, so I'm not sure if like, yeah, if it's helpful to say have an implementation in Geth, or if that's just, you know, so different from what you all have. Yeah, I guess, I don't know. Yeah, what would be kind of the way for you to like feel more comfortable about that? Is it just taking more time? Is it seeing a proof of concept? Yeah.
Well, it's probably a relatively easy change, so we can do it, but it's like it will be some development work. It's not like changing a single constant, right? So it will delay the merge more than just like changing a single constant.
I even want to point out that we could make a 4499 90 92 like, you know, before and then do 4488. Like there are not, I mean, there are 4490 is just a simplified version, and 4488 goes just deeper.
Right, but then are we okay with the possibility of 5 megabyte blocks?
Yeah, that seemed to be.
I mean, that's a very good question, and I don't have a good answer for that. I don't expect, I mean, those to actually happen, because obviously there is like there is a max size transaction by a Geth, which is 100 kilobytes, which all mean that every time we're going to publish a transaction, there is at least 20,000 gas spent on the signature itself, like, you know, the base cost. So we will never get to that numbers, but I didn't quantify the actual mass.
Right. Right, but then if the argument is that we'll never actually get to it, then that's also an argument that like whatever the issues with optimization, with block optimization.
Right. I think the thing we need to remember is that if someone can like crash the network or break the network or whatever by making a 5 megabyte block, we will see a 5 megabyte block. I don't think the question is, are we likely to see one naturally? It's, will one break the network? And if so, we will see it.
And block production often bypasses the mempool. So the mempool doesn't necessarily, like the validations in the mempool doesn't really in today's practice bound what is going to go in there.
That's a very fair statement. I don't have a clear answer for that. It's also notice, as someone said, that in the worst case, due to 1159, it's also go to 10 megabyte on the worst case. In the worst case scenario, when because of 30 million gas.
Well, isn't like 30 million divided by 6 gas the 5 megabyte block? Isn't that the worst case?
Let me check.
Yeah, because I mean, if it's 6 gas per byte.
Right. You're right.
Gas,
I got confused. Sorry about that. I got confused.
Okay, so the worst case is a 5 megabytes, not a 10 megabytes. And obviously that's worth noting that like it's easy to send one of these worst case blocks, but then if you're spamming the network with these 5 megabyte blocks, the cost goes up exponentially. So you can't send like 100 5 megabyte blocks in a row. The cost to do that would just like be millions of ether with the base fee going up.
Exactly.
Yeah, but
no one will sustainably be able to push those blocks.
But you can send 10. You can basically send 10, wait a half an hour, send 10, wait a half an hour. That's like a expensive but not like completely out of reach strategy. Yeah, or do 2.5 megabyte blocks forever. Yeah.
So just to add, since we're talking about 5 megabytes or 10 megabyte blocks, I wanted to add that that peer-to-peer has a message limit of 10 megabytes. So essentially a 10 megabyte block would be impossible to propagate through the Ethereum network. Probably possibly 8 megabyte is, I don't know. So I'm not entirely sure what the payload caps are, but I think Geth has a cap of 2 megabytes or something. I don't know. It has a pretty aggressive cap on how much it's willing to forward. So that's one potential issue. And another potential issue that we should not forget is that block propagation is essentially every block is forwarded. It's announced to all of the peers, but it's also forwarded to square root of your peers. Now, if Geth by default runs with 50 peers, that kind of means square root of 50 is what? 7. So you will actually propagate it to 7 peers, and you kind of expectedly is going to get it from 7 other peers that you have. So it's going to cross your network line 14 times. So if you have a 5 megabyte block, that's 70 megabyte of data traffic just for that one block to propagate through the network. That's a pretty hefty bandwidth requirement.
Right. One thing, sorry, Lucas, I'll get to you right after this, but one thing that's worth highlighting also is next call is the last call of the year. So next all core dev calls will be December 10th. Then the next one would fall on December 24th. I don't think anyone here wants to have a call on Christmas Eve. And even if some people did, we'd probably get quite low attendance. And if obviously we're talking about potentially doing one of these changes before the merge, we probably want to have consensus on it. If not, by the next call, definitely by the absolute first call in January. And so I think it's just worth kind of highlighting that, like, to see, I don't know, like the people think we should like basically plan out, think about, prototype a potential fork for this in February. I don't think we need to agree to it today. And if so, basically, what are the things that we want to figure out in the next 2 weeks, right? Like, and can we potentially come back with that and make a decision, or like get closer to a decision on the next call? Just because, yeah, if we are doing this before the merge, we need to make the decision sooner than we otherwise would.
Can we make the decision today on committing to 4444 or something along those lines, so that way we can start the outreach process sooner rather than later? Is there anyone that disagrees that we should do 4444 or some derivation?
There is some community disagreement over the change in security assumption for optimistic rollup. So I don't know if the community will not fight those. I already seen someone on Twitter being extremely active against 4444.
Question on that maybe, because you might be the person to ask. Isn't, because we expect rollups to move to sharding data availability in the next 2 or 3 years anyway, and sharding, as Dan quite pointed out, has already the same security as guarantees of only kind of like providing like data availability, like of the current data, but not the history. So isn't it the same situation that we have to end up long term anyway?
Yes.
Yeah. And I think it's a misunderstanding. Like people confuse data storage and data availability. These are different properties. And I don't know. Like Luis, did you get this from any actually like rollup people? I know there was someone on Twitter who did that, but I think they didn't understand the problem properly.
So from a perspective of ZK rollup, there is a solution to 4444, which is to have like an off-chain queue of latest like when slots were touched or modified. So that wouldn't be too. I mean, there is a way around for ZK rollup to manage that. I'm not familiar how optimistic rollup can sustain this change assumption. So I can talk on behalf of Optimism and Arbitrum here.
Andrew?
Yeah, so we discussed 4444 inside the team, and we are not opposed to it. So Aragon is in favor of it.
Nice.
Right, and I mean the assumption is that 44 is coupled with historic block distribution standards that are outside of the P2P network, and that if the blocks are available via any of these standards, you can always recursively validate all the way to the base of the chain via knowing recent information, secure information about the head. And so the expectation on data availability is that data is made available, and then those that want it have it and can use it, and there's not security risks around data withholding attacks. And then once it's made available and infrastructure and communities are utilizing it, then it's ultimately their problem to store it in the long run.
Yes, agreed. Like basically, we should be careful because data storage is not an attack vector. You can't make someone forget data. You can only withhold data in the first place. That's an attack vector.
So when it comes to rollups, we don't have optimistic rollups people here, but since Starkware is here, how does Starkware, why would 44s impact the ZK rollup? Where would the rollup use data older than a year old?
That's a very good question. For the ZK rollup, I think there is a solution, which is, as I said, keeping queue of the like data being stored on like when it was modified and published, and republished it before the destruction of the data to guarantee that availability over time. What I'm saying is, of course, we require engineering work, and it's something that would be quite like an extensive modification of the what we call core OS of StarkNet. We can manage it, we can probably work around it, but what I'm saying is, the optimistic rollup, I can't talk on their behalf, so they should come or we should reach out.
To jump in there, I understand what you're doing, but I think you are operating from an extremely pessimistic security model, and I think what you do there is not necessary, and there are smarter ways to do this. So you're basically saying you basically want to use the Ethereum data availability layer as your storage layer, which is what your solution does, and I don't think that's what you should do.
I mean, I'm just saying that if we want, I'm just reflecting on, I mean, something we haven't discussed it publicly, internally, whatever. I'm just reflecting.
I understand that. And
on the assumption on rerunning the network and being able to reconstruct the storage. Under 4444, I do think ZK can make it. I don't know for optimistic wrap, and this is the concept. Maybe we should change the security
but I think basically, the reason I'm correcting you here is because I think you're spreading fat. I don't think like you are having a super pessimistic security assumption that you say everything has to be reconstructable from the current data availability layer. And I don't think that is the right assumption.
Sorry, just because we have only like 5 minutes left. Obviously, 4444 is going to need a lot of community outreach. I suspect whatever version goes live is probably not exactly what's the ETH today, but something like it is probably like has to happen at some point.
Agreed.
Yeah, and we can't. I don't know, like we can make some commitments towards like pushing this and whatnot. I think we probably can't do that in the next 2 or 3 minutes. What I think we can do is try to highlight, like, you know, what do the different teams want to see to be comfortable with 4488 in the next 2 weeks. And so obviously trying to have implementations across all clients is one thing. And then Andrew's concerns about like, and others have raised this as well, but just around like how you do optimal kind of block packing. I'm not sure if that's something we can get done in 2 weeks, but it might be something that even say we have, you know, the client implementations ready. We still need to figure that out, but we don't necessarily have to block everything on it. I don't know how, like, would most client teams have the bandwidth to prototype this in the next 2 weeks? If not, I'm happy to reach out and try to find teams or contractors that can work on prototypes. Yeah, I guess I'm curious, yeah, how realistic is it for like client teams to actually spend some of their cycles on that in the next, on 4488 to be clear, in the next 2 weeks?
Nevermind can try to prototype it in this 2 weeks.
Cool.
I just want to correct one thing before we drop. Don't cry. I'm not trying to fun. I'm just, you know, I was just expressing the current security model, and maybe the security model can be changed, and I agree with that. 444 is a necessity. There is literally no doubt about it. I was just saying that we should.
I think we should take that off the call. We should take that off the call. But I'm happy to explain to you why I think it should be different.
And to those listening, it is critical that it becomes the model if you plan on using data sharding, because that data sharding is not going to provide persistent data storage guarantees for all time.
So, Tim, one thing that I would really like to see is what's the worst block? What's the worst, like with the current packing algorithm, if we change it to this new one, like what's the difference between how different can this block be from like a really like smartly packed block? And if someone could work on that, that would be really, really nice.
And by the worst, you mean the most damaging for the network, basically? Or
no, I mean like given a set of transactions and like a smart algorithm to pack them, how much overhead can there be to like the naively packed version of that block?
And when you say overhead, you mean kind of like lost profit for miners that kind of like just leave transactions out? Okay, because I think it does make sense to kind of analyze like an artificial worst case, because you can always construct a case where basically transactions are pending in just the right way that you kind of like lose out on a lot of profit. But like I mean, that's not an attack vector. Kind of like taunting someone with potential profit and then not giving it to them. That's not an attack. So basically, what you'd have to look at is just like historically, like historical, just real world blocks, and say, okay, if we had this naive algorithm, basically, and we just assume there would have been one extra big transaction in the front that used up a lot of the call data cap, kind of like how much would you have left on the table? That might be an interesting analysis.
Is that something you have the bandwidth to look at, Ansgar? Because you seem to understand the problem pretty well, and
Sure.
Given the short timeline, yeah.
I could do that. If someone else also wants to look into this or something, feel free to reach out, coordinate.
And yeah, so basically, so there is a PR against Geth. Nethermind can prototype. Aragon can probably pull in the consensus changes, but not the transaction pool changes. And it would take some extra bandwidth to do that. Besu, okay, so there's a comment by Besu. Is this something you think you could prototype in the next 2 weeks, or is this something where if somebody submitted a PR to Besu, it would make your life much easier?
Yeah, we're always open PRs. 2 weeks for a prototype would be tight for us, but I'd have to talk to the rest of the team.
Okay. So I guess let's see what we can do in the next 2 weeks. If you are listening to this call and like you've got a Java or Go background and you can help with PRs, please reach out to me. Yeah, we can definitely kind of find or set up some bounties and whatnot for that. And yeah, I guess in 2 weeks we can get back here and discuss and see kind of with the progress made, how realistic is it to put this potentially before the merge.
I think that the ES can also commit to providing resourcing for pushing 4444 along throughout 2022.
Yeah. Cool. We are 1 minute away from time, but there's someone on the call who had a quick shout out. So Zach is here. He's working on a documentary about Ethereum called Infinite Garden. So he'll probably be trying to reach out to a bunch of people on this call and others in the community over the next few months. It's already started. So yeah, I just wanted to give him a few minutes to kind of explain what they're working on. And yeah, the floor is yours, Zach.
Thanks, Tim. Yeah, I just don't want to take too much time, but wanted to jump on, and obviously we are huge fans of the work of the core devs, and we're making this film called Ethereum, The Infinite Garden, which was actually funded by the community via a Mir crowdfund on Mir. And it's allowed us to kind of focus on how Ethereum is already affecting people's lives around the world. We've been filming all around the world, and how Ethereum will affect people's lives in the future. So we're filming through the merge, and obviously the work of the core devs is fundamental to the story of this film. So I just wanted to jump on, and if we pop into your telegrams, I wanted you to know who it was. So we'll be talking to a lot of you moving forward, and yeah, really just appreciate the time and all the work you're doing.
Thank you. Where's the best place for people to reach out if they want to ping you, they have something interesting to share?
Yeah, absolutely. My email is zach@optimist.co. And you can check out all our work, our previous films that were on Netflix and HBO on optimist.co. So you can check out the website, and our contact info is on there as well. But yeah, probably email is the best.
Awesome, thanks. Yeah, and one last quick thing before we go. Trent is organizing a merge community call next week at all core devs time, so 1400 UTC, which is now a new time in I guess Europe and North America because of daylight savings. So yeah, if you are basically an infrastructure provider, tooling provider, application that wants to see what the merge is, what's happening with the merge, ask your questions, get the updates, please come next Friday. There's a link in the chat here. It's on the Ethereum PM repo for the agenda. And yes, final shout out, please update your nodes. If you are running a node on the proof of work network right now, Arrow Glacier will have happened before the next Awkward Devs. Yeah, happy Thanksgiving for Americans. And yeah, thanks for anyone in the US who made it on this call. Much appreciate you spending your holiday weekend here with us. And yeah, I think that's it. Thanks a lot, everyone. This was really, really good.
Thanks, Tim.
Thank you, Tim.
Thank you.
Bye, all.
Ship all the things.
Thank you.
Thank you.
Have a great day.
Thank
Bye-bye.
you.
Thanks.
Bye.
Bye.
Come over to the 4-4 side.